For centuries, the whole point of science was pretty simple, right? To paint a clear picture of the universe in our heads. But what happens when we get to a point where we just can't? What if the universe, at its very core, isn't something our brains can ever really visualize? Now, that's not some student confessing after a tough exam. That is Richard Feynman, Nobel Prize winner, one of the absolute sharpest minds of the 20th century. And he's admitting something that should stop you in your tracks. He's saying the very bedrock of modern physics, the theory that makes your phone work and explains the stars, is just beyond our ability to truly get. And that right there is the huge question we're diving into. If human intuition has finally hit a brick wall, is that it? Are we at the end of the line for scientific discovery? Or is a totally new kind of intelligence about to take the lead? To really get where we're going, we first have to understand the problem that Feynman pointed out. It's this deep, fundamental mismatch between the world our brains evolved for and the universe as it actually is. This was Feynman's genius. You know, our common sense, that gut feeling for how things are supposed to work, it's a survival kit. It's for a world of medium-sized things, like rocks and trees, moving at pretty normal speeds. It is completely 100% useless when you zoom way, way down to the quantum level. Just try to wrap your head around superposition. Our brains are hardwired to see a thing in one place at one time. But quantum mechanics says, nope. An electron is more like a cloud of possibilities. It's here and there and everywhere in between, all at once, until you measure it. It's a concept that just breaks any mental image you try to make of it. The wave function is the perfect example of this whole problem. It's the absolute heart of quantum theory. But you can't picture it as a wave in the ocean. It's not physical. It's a pure mathematical tool that tells you the odds of all the different possibilities. We can use the math and it works perfectly, but we can't for the life of us picture what it is. So here's the kicker. Physics basically became a prediction machine. We plug numbers into these bizarre mathematical equations and out pop these incredibly accurate predictions about the world. But that satisfying picture in your head, that deep, gut-level I get it feeling, that got left in the dust. We have the instruction manual for the universe, but no idea why it's written the way it is. So for decades, physics has been in this weird spot, you know? We're dealing with ideas like dark matter and wave functions that we can calculate with but never really see. But now, a totally new kind of intelligence has shown up, one that absolutely thrives in this world of pure abstraction. See, AI doesn't need a mental picture. It couldn't care less about intuition. It works in the native language of modern physics, which is just pure math and finding patterns in data. That makes it the perfect partner for a science that has long since left our human understanding behind. And this isn't just some theory, it is already happening. A recent study found that scientists using large language models are seeing a massive explosion in how much work they get done. We're talking a 40% increase in published papers on average. And for scientists who aren't native English speakers, it's a mind-blowing 80% jump. And it's not just about getting more papers out. The people with the money are paying very close attention. OpenAI is pouring $50 million into getting its top-tier AI into the hands of the world's best universities. The very places that create the future of science are all in on this. Like NVIDIA's CEO said, intelligence is about to become a commodity. Think about that. The raw ability to process information and spot patterns is no longer a uniquely human skill. It's becoming a utility you can just plug into, like electricity. The ripple effects from that are going to be huge. Make no mistake, AI is already woven into the fabric of science. Over half of the people who peer review new scientific papers are using it. Top mathematicians are using it to find brand new proofs. It's writing grant proposals. This isn't some revolution that's coming. We are in the middle of it. Okay, so let's put the two halves of our story together. On one side, we have Feynman's problem, a universe we can calculate but can't really picture. On the other, we have a new tool, a mind that is a master of calculation. So what happens when these two things finally meet? You get a complete shift in how things are done. The human scientist, for all our brilliance, has limits. We're slow, we have biases we don't even know about, and we're chained to this need for an intuitive picture. The AI scientist, it has zero of those problems. It was basically built for the strange mathematical reality that physics has been telling us about all along. And this leads us to a pretty radical thought. An AI doesn't need to understand a wave function like we do. It just needs to compute what happens next. It doesn't need a mental image of dark matter, it just needs to analyze the data from the galaxies. Suddenly, scientific discovery might not be about understanding at all. It might just be about computation. And the timeline for this change is just shockingly fast. Physicist Sabine Hossenfelder maps out this wild trajectory. The US government is already building a national AI platform just for discovery. The productivity gains alone will push adoption to nearly 100%. And within a decade, she predicts that theoretical physics as a human job could just be over. Just let that sink in for a second. Not 30 years from now. 3. She's saying that the work that grad students and postdocs have been doing for generations, the real engine of science, is about to be done by AI at a tiny fraction of the cost and time. This isn't a small change. This is a complete teardown and rebuild of how we discover things. So, we're left with this massive question. We started this journey because our own minds hit a wall trying to grasp the universe's biggest secrets. So, are we building a tool that will finally give us the answers, acting as a translator for the untranslatable? Or are we just building our replacements, handing over the very act of scientific discovery to an intelligence that doesn't need us or our understanding at all?